Welcome again. If you're just joining, posted a question in the chat if you want to introduce yourself. Also, throughout this presentation, if you'd like to post any questions you have in general, we're going to do a Q&A session at the end. Right. Welcome. I'm going to get started now. Thank you everyone for joining. This webinar is being hosted by the Texas Society of Architects Committee on the Environment. I am the chair of that group this year. Our committee is about 12, 15 people. So if you're ever interested in getting involved at the state level, we have applications that open every year. But our mission is here, which is to work to advance and advocate the design of sustainable, resilient, healthy, and equitable communities through public policy, outreach, and educational opportunities like this. So we'll get started. This is a two-part series about the AIA 2030 commitment. I'm also on the 2030 working group, so we felt that with TxA and 2030, this would be a great opportunity before reporting closes in late March to talk about both topics. We did record operational energy, so if you want to see that later, we're going to be posting it on our YouTube. But for now, we're just focused on embodied carbon in this session. So for our agenda today, we've got a great lineup of speakers. I'm going to start us off with an introduction to the 2030 challenge. If you're not familiar with that, a little bit about what it means to report embodied carbon this year, since some things have changed. And then we'll have a couple of different case studies, Philip Smith with DLR Group, Chell with LMN, Ty with Co-Architects, and then Jack Rusk is here with C-Scale, who's going to do a quick demo of that tool, which is great for reporting embodied carbon this year. And then we'll save some time for Q&A. So if you would like to post questions in the chat along the way, we're going to save those for later. Okay, so let's jump into the introduction on 2030 challenge and embodied carbon. So if you're not familiar with the commitment, in 2005, Architecture 2030 issued the 2030 challenge, which was to reduce our energy operational emissions by 2030. And through that, the AIA then created the AIA 2030 commitment, which is a formal commitment that your firm can sign up for. And it really was supposed to be setting standards and goals to reach that net zero emissions by 2030. There's over 1,350 signatory firms who have committed to this, and it's been open for quite some time too. So happy to tell you more about that process if you're interested. So if you're not already signed up, it's pretty easy. There's a commitment letter that you sign. You create a sustainability action plan. You report all of your projects each year, whether they are high performing or not. It's really just about transparency, and then regularly update your action plan. So that's what it means to be a committed member to this. And as I mentioned, the 2030 commitment mostly focused on operational carbon in the past. However, because we are now moving towards total carbon impacts, we're trying to include things like embodied carbon. And so if you're not familiar with embodied carbon, it's the emissions that are associated with building materials. So pretty much the whole life cycle of a product, from extraction of that material, manufacturing, transportation to and from that process, and to your site, as well as installation, maintenance, demolition of those building materials. So that's what we're focusing on today. But when you put those things together, we get our total impact that we can have as architects and the built environment. And this topic is really important because, in addition to our building operations, we also are able to impact our carbon emissions through the materials that we select. Something that we really have a true impact on, and especially certain materials like iron and steel, cement, these have quite a big impact globally on our carbon emissions, which is why we're really trying to hone in on how we can impact carbon emissions beyond operations. And One of the things with materials, right, is that we select them right away. And so that carbon impact, that upfront carbon impact is something that you see the second that you select those materials and they get implemented versus operational carbon, right, which is the whole lifespan of a building. Both are equally important, but when we think about things that we can do right now, today, our materials are extremely important, and which is why we want to see people reporting these impacts more and more. And if you're not familiar with how to measure embodied carbon and some of those life cycle impact stages, these are some important terminologies to know that you'll see in the 2030 reporting project categories. So you have your product stage, which is A1 through A3. You see these on things like environmental product declarations. This is the material extraction, transportation, and manufacturing of a product. There's construction phases, which is A4 and 5. Grayed out here, I have the use stage, which is actually, part of that is the maintenance and repair, but also your operational energy, which is a separate reporting category, and then the end of life situation. All these graphics that I just showed are part of a really great resource that the AIA and Carbon Leadership Forum have put together, which is a toolkit for architects. I highly recommend. It's a 3-part series that go through introducing embodied carbon, measuring, and then strategies for reducing. And if you're not involved with Carbon Leadership Forum, they're a great group and they have committees all over the country. You can see this little map here. So we've got quite a few just in Texas also that they do their own webinars. So the DDX platform is something you log in to access once you're signed on for the commitment. So it's a nice online platform to do your reporting. If you're going to be reporting a project, it really only takes 5 to 10 minutes. It's quite simple once you have your data collected. The basic project setup looks like this. So you need your project name, where your project is located in the world. The postal code and things help you establish climate zones. So some of this is auto-populated. And then you can report things like new construction, renovation, or interiors only. You then need to know your occupancy year. This doesn't have a huge impact, so just make your best guess if you don't know. But an important aspect for the operational side is knowing the correct energy code to be put in here. You then need to know your use type, like is it an office, a residential project, whatever it might be, and the conditioned area in square feet. Once you have that project set up, that's set up for the life of the project. So every time you report at each phase, SD, concept, DD, whatever it might be, you go through and track that data at each phase. So ideally, at least once a year, maybe more as you move through the phases of design. If you're doing just operational energy, it's pretty simple. You select the phase that you're in the reporting year. And fill out that information. Again, our other webinar walked through this process on energy modeling, so we won't talk about that. But if, say, for example, you only want to report embodied carbon, you only have a code compliant building, you just hit no and then move on. This is going to say that I have a code compliant building and I'm just focused on embodied carbon, for example. So as you scroll through, this is all on one page. So once you hit track data, you scroll to the bottom, and that's where you see embodied carbon. And so again, technically with reporting, it's just about transparency. So if your project is code compliant, it didn't do embodied carbon analysis, just keep everything on no. Like we still want to know that that project exists in the world and it didn't do these things. So reporting is whether you're high performing or not, we still want to see that data. So it's totally okay to hit no if you're not reporting that this year, or maybe you only want to report a couple projects. If you are going to be reporting, you just click yes instead, and a drop down will populate on that same page. So if you are going to report embodied carbon this year, it looks different than past years. They've added quite a lot of new data and interface collection for this. So you input things like your modeling year, your tool version, project phase, but most importantly, they're asking for this in square meters. So just make sure that you're filling that in properly. The updated square meters here. Who did your modeling in the tool that you used? And then from there, there's 2 different options that you can do. One is a detailed entry analysis, and others is just like an override, which I'll show in a second. So again, the little asterisks show the stuff that you need. But the reason I explained the different life cycle stages is because this carbon reporting does allow you to enter quite a detailed amount. So you can see on the left-hand side, we have different categories of the building that you can report on, and then your different life cycle phases. If, for example, you only did structure, that's okay, just report that. Or maybe you didn't do MEP and site work, just fill in what you have. The most we can fill in, the better, but it's okay to say only just do structures and enclosure, or maybe interiors, whatever works best for your project. But if you don't have this detailed breakdown, say you used a simplified tool and you only know your total kilograms per CO2 per meter squared, you can just do the override and enter that too. But just make sure you're paying attention to that unit here, kilogram CO2 equivalent over metered squared. So not just your kilogram CO2. So again, two different options you can do here, detailed or simplified version. Additional optional data that you can enter in that would be helpful for the 2030 group to know is reduction strategies. So what did you do to help reduce embodied carbon on this project? It's just a narrative. And then biogenic carbon, did your LCA include the sequestration and biogenic carbon impacts? So then just briefly some resources. If you need help in this process at all, just general 2030 related things. There's a whole 2030 commitment contacts here, and then also they're doing some webinars. So there's 2 left right now on how to submit your portfolio and last minute questions. There's also this really great DDX support page here, and I'll post some of these in the chat, but it goes through tons of detailed information about this process. So if you have questions, you can always reach out to the folks at AIA or maybe start here with this support link. They also have an AIA 2030 peer-to-peer network group, so you can post your questions and see what other people are asking online. And again, I'll post some of these in the chat. So that was just a quick run through. You are welcome to ask questions in the chat. We can talk about them later about embodied carbon, but really just wanted to give the floor to our guests today. So we have, again, Philip Smith, Chell, Ty, and Jack, who are going to be doing some case studies about how their firms are incorporating embodied carbon into their workflows right now. So I will hand it off to Phil. Stop sharing.
Hey everybody, can you hear me?
Yes.
Okay, so let me make sure I'm sharing the right screen. One of my favorite pranks during the COVID years was to say, hey, did you mean to share screen just on any meeting? Anyway, okay, so my name's Phil Smith. I am an architect with DLR Group. I have been in this firm for 4.5 years. In that 4.5 years, actually just since 2018, that's when studying embodied carbon really became popular. I say popular, although in those early days, it was really just Carbon Leadership Forum, and I think it started out of University of Washington. Shell can back me up when he talks later if that was correct or not. And so as a firm, we have been wrestling for years on how exactly to do this measurement, on how exactly to structure a firm that is right now, I think we're at 1,800 employees and we're growing more and more every year. We're targeting like lots of growth. And so we're really looking right now at a firm-wide strategy and also making sure that we can meet our commitments. Speaking of commitments, we have been reporting on DDX since the beginning. We signed on to A 2030 in 2009. Something kind of interesting about this slide on the right there, that's the original submission. You'll see the signature on the bottom right, Steve Mackay. And so more than 10 years ago, our current CEO, who was not then the CEO, he is the one who actually signed our commitment. So you can see the importance as a firm towards this. And now it's a matter of what are we going to do to actually have everybody report our embodied carbon. And so, thanks, Jack. And so we've been looking at a lot of different ways that we can incorporate sustainability into our culture. We have been focused on carbon operational and embodied for the past couple of years. This year, we're starting to widen out a bit more to like water, to resiliency, to health, to equity, and things like that. So we have a pretty rich history in terms of reporting carbon. But even still, just as a firm as wide as we are, 100% employee owned, there are lots of variances. And this is something that I have been tasked with the architecture discipline in terms of trying to figure out how we can narrow it down. And so part of this is climate literacy. In other words, making sure all of our employee owners understand what we mean when we say embodied carbon, understand what the platforms are, and just kind of get this like basic level of understanding lifted across the firm. And so that's something we've really been focusing on. We've also been focusing on, as you can see here, performance analytics. And so this to me would be our life cycle assessments. We've been working on getting climate strategies on every project where we're actually going to target some sort of reduction in either embodied or on operational carbon. And so you can see it's a really big process to the point where we even got our own carbon footprint as a firm. And so we're really proud members of the AIA 2030 Challenge and the Large Firm Roundtable. This is something that is just built into our DNA at this point. Kate did a great job explaining this, so I'm not going to get into it too much. But when I say we've been targeting carbon, it's embodied and it's operational. We also have a big focus on site, making sure that we're looking at our pavement and things like that. Here is kind of where we were heading with that graph, that Carbon Leadership Forum graph about the embodied carbon in a building. And so this has been a focus since about 2018. We've been really focusing before that on operational energy. And so now as time goes on, our operational energy has really shrunk. But what have we really done for embodied energy? And like I've been saying, it hasn't been consistent, at least within our firm. This is a graph that looks familiar. Again, Kate kind of covered this already. It's a matter of when are we calculating our embodied carbon. We've got that initial fabrication of the building and transportation of materials, et cetera. We have some sort of renovation after about 20 or 30 years, depending on the building. And then at the very end of the life cycle, we've got some sort of either recycling effort or scrapping the building. And in terms of measuring, we already saw something like this. So we understand that there's a product stage, construction stage. During the use stage, the operational lives there, and we have our end of life. And then we have, what's going to happen when our project is done. And so focusing on the whole use of the building is something that's been just vitally important. Within the LCA, we are not focused necessarily on all of this, but we are making sure that we're at least keeping in mind the cradle to cradle mentality. So we already talked about the AIA 2030. Okay, so as a firm, this has been a real sticky topic. I do represent architecture discipline within our embodied carbon working group, but we have all of our disciplines. We're an integrated design firm. And so structure has really been leading the way, and they have really focused on Tally. Tally is a Revit plugin, and this is something that can use your Revit geometries to it can use the Revit geometries to tally, basically get material takeoffs, and then it can transport that information into EC3 so you can assign your environmental product declarations. C-Scale is another really important tool for us, especially early on when we're comparing different things, or if we're wanting to submit for DDX and we don't necessarily have the project budget to run a full Tally model, because Tally is a lot more intense. I'll get a little bit more into the weeds on the difference between these two and how we use them. Oh, actually right now. So with C-Scale, we really like it for our early phase stuff. We really like the cost part of it because this is something that everybody can use. It's very user friendly. You can refine your scope, you can override your defaults, you can make it work for your project. It's just a really user friendly way of getting just basic embodied carbon data. Now, obviously it has drawbacks because it's meant to be so user friendly. And actually there's a C-Scale person on the call, so I'm sure he is going to be talking about this even more than I do. So I'm just going to move past this one to Tally. As I mentioned, this is a Revit plugin. You can create baseline models, you can compare other models. There is a lot more to learn with this software, with this software platform. And once you get it, you can get really great information. There are many other platforms out there that are maybe not as cost effective. You probably are familiar with OneClick or some of the other ones that others use. And I've used them too, and I also like them. But as a firm, we're really looking at C-Scale and Tally. So as a workflow, it's not just a life cycle analysis for the information to be submitted to DDX. Even though that is a very important part of this because we are committed to the A2030 cause, we actually want to do something with this information. And so trying to figure out when to do life cycle analyses, what kinds, what are we actually looking at in each of these phases. And so within our schematic design, we're really looking at our building components. When we're looking at design development, we might have two options and we can actually compare between the two. When we're doing CDs at this point, we're looking at something more summative. We're looking at a full-on report, and we're actually assessing the embodied carbon. When you go to your project procurement, it's possible that you're going to get some product data in and you want to compare things. And finally, in construction, we're going to do our final calculation, and that could be for certifications or other things. For this first one, the whole building life cycle analysis versus the comparative, this is just your initial snapshot versus like your actual systems. And so if you are wanting to compare two materials, if you're wanting to compare your cladding systems differently, you would do a comparative life cycle analysis. You wouldn't want a whole building because that takes a lot of time. If you are going to do a whole building, then this is basically going to be your way of communicating with the client or with certification experts. This is what you think you're contributing to your carbon footprint. So an example of this whole building versus this comparative, in this case, we were looking at a facade. And within this facade, we very clearly see one outperforming the other. And if this is a tie, if everything else in here is a tie, like we like both designs or whatever, at that point, we can look and say, here's our tiebreaker. Or we can make this a priority and say, we're really going to focus on making sure that our building has very low embodied carbon, in which case we might start from here and then refine further. Here's another example of an analysis. This is a comparative life cycle analysis, and we're just looking at the facades. So if we've got a great maple versus a tangential maple, a radial maple versus a tangential maple versus just a solid. So those were the three that we had looked at. We can see in terms of their output, how they perform with one another. And so if you're following this line here, there actually is a difference in these facade systems. In this one case, it's a matter of this steel sheet and how much that contributes to the overall embodied carbon footprint. Another case, you might look at your wall assembly and try and narrow down where you can reduce your embodied carbon. What is it in this assembly that's causing issues? And so in this case, we're just looking at a wall section, a typical wall section. And this is an output from Tally that you can get. It will take your wall system and it'll divvy it up into what is taking up the most space in the carbon footprint. And in this case, we can see that it's a division 7. We're looking at this polyiso board. And so what can we do with that information? We can actually take a peek at each of these styles. And so in this case, we're evaluating the polyiso base versus a rock wool. And across the board, we can see that rock wool is outperforming, except with the ozone depletion potential. It's pretty close. And so again, if this is a choice, if everything else is even, and then this can be a tiebreaker, obviously cost is going to be a big factor in these sorts of decisions. And I don't think I'm quite running up on my time yet, but just in case, this is going to be the last thing I show is the Ismaili Center. This is a new project here in Houston. It's been transformative for the community. Everybody has responded positively to it. I've been out there a few times already. I got to see it during construction. This is just a really great project to look at for so many reasons. And one of those is the amount of fly ash you can actually put into concrete really shocked me. And so to start off with, this is LEED certification. We were looking at the different LEEDs that we could get. If you go with version 4 LEED, you have to implement changes to your analysis required for that 10% improvement in 3 of those 6 areas. In version 4.1, you can actually get a point when you run the analysis, and you can get additional credits for achieving reductions as compared to a baseline. And the establishment of that baseline can get a little complicated, and so I'm not going to get into that today. But in this case, I do have a little note here on that baseline of what is required. So in looking at what we're doing to actually lower our embodied carbon for the Ismaili Center, we have ways of evaluating the building and trying to figure out exactly what it is that we're measuring. And so we can break up our life cycle analysis into different components. You have your exterior screen shell, you have your structural model, and you have your architectural model. And when you're looking at each of these, you can compare what's happening within each of these systems, or you can just kind of get your summary number from the whole thing. It's basically just math. What's your exterior embodied carbon load? What's your structural embodied carbon load? And what's your architectural? What we found, next slide, please. There we go. In terms of where our embodied carbon was, I mean, it's no surprise that would be concrete, right? And with the concrete, we're looking at all sorts of other things like eutrophication and other environmental concerns. But in terms of the cement production within concrete, that's really the major contributor here, to the point where it's about 76% of the global warming potential within the project. In looking at it by material, just within the concrete itself, you can see that we've got our admixture. We have quite a bit of fly ash. We've got our fiber reinforced concrete, more glass fibers, et cetera, et cetera. And the nice thing about Tally, and there's some other things that do this, is it can break down where your different components are coming from. And so in this case, it's the structural concrete has a lot of that cement in it. And so what we ended up with the Ismaili Center, we ended up with a reduction of, I think, 8%. The global warming potential was 38 million kilograms of carbon dioxide equivalent. And so it's the equivalent of about 9,000 cars just with the concrete. Now, to reduce this against that baseline again, we looked at a couple of different things that we could do. So there was the fly ash being incorporated into it. Now, something that really prominent about the Ismaili Center is the color white. Is just how the colored concrete manages to look so vibrant. And when you add fly ash, we know that that can kind of gray things out. And so working with your general contractor early on to make sure that you can get that color. Our architect of record for this project, man, she has a lot of stories about her interaction with the contractor on this project. But towards the end, we ended up with 35% fly ash in just the general concrete, structural concrete. But any architectural concrete is more than half fly ash. Now in Texas, I'm sure there's going to be questions on this. Sure, I see Margaret's note in the chat here. There could be a longer cure time for these lower carbon admixtures. And so this is something, again, you just work with your GC about to make sure that it gets scheduled out correctly. But yes, that can absolutely be a concern. The other concern is where you're actually getting this fly ash from. Fly ash is, as probably most of you know, it's a byproduct of the coal power plant. And so if there aren't a lot of coal power plants around, you're going to have to ship it in from somewhere. But even still, the carbon footprint of cement is just so high that it typically is always worth it. And so that is taken into account with our tally model, by the way. And so in the end, we had an 8.7% reduction across the whole building life cycle analysis. So it's almost like by incorporating all of that fly ash, we took 730 cars out of the project. I think, yeah, that's all I have for the presentation today. If you want to send me questions through the chat, or I can hang on up for a little bit after if you have any questions, but that's all I have for today. Thank you all.
Cho, we can't hear you.
Okay, now you can hear me. All right. I'm Chell Anderson. It's pronounced with a CH at the beginning. And I am with LMN Architects in Seattle. We are a multidisciplinary firm, architects, interiors, urban planning, and technologists that work together on convention centers, performing arts, higher ed, and many other building types. We're around 100 people in an intentionally single office so we can know each other and collaborate. So I am the Director of Sustainable Design. I work across all of our projects to set and implement the goals and aspirations for all of our clients. And I also serve on the Building Code Council in Washington to advance the codes and also get to see what is becoming standard out there in the industry. So the technology exists right now for operational carbon neutral buildings, which is part of the 2030 challenge. You go all electric, and then you either buy renewable energy or you wait until the grid decarbonizes. And the Texas grid leads the U.S. in deployment of solar, wind, and batteries. Because they're cheaper, so that's likely to continue into the future. As a context for the image on the right, Element is a signatory to the AIA 2030 commitment. We believe what gets measured gets managed, and you can see the kind of light green line there is our progress, and you can see it goes up and down, but it eventually gets us. So the last 2 years, we've met the 2030 challenge as a firm with our average square foot. But that's based on a few things, which are third-party energy modeling on all projects, internal education on electrification, and the cost of renewable energy is becoming cheaper than fossil fuels in most cases. So it's become a part of a lot of our projects. So what does this mean for us? It means that as we reduce operational carbon, as been said before, embodied carbon is all of our remaining carbon pollution. So starting in 2020 or so, we analyze embodied carbon on all of our major projects using TxA. We put all of our analysis into a database, and you see on the right, concrete and steel are basically 2/3 of all of our embodied carbon that we've tracked. So it's an obvious focus. But of course, this database is mostly structure and envelope. So there's a lot of things that are just not here, like MEP, site work, and other things. We've also figured out how to get to about a 30% embodied carbon reduction in concrete in every market across the US. So we meet with a structure, contractor, sometimes concrete suppliers to understand which mixes, kind of like what Philip was talking about, to understand which mixes can include very low carbon concrete and which are more time sensitive, and we should maybe just use more of a standard mix. And we have good spec language now to address all of that. Since structure is a major part of embodied carbon, we have a detailed list of what can be done in each phase for structural embodied carbon. This is part of a free online resource we call the Path to Zero Carbon series. That's on our website. I'm not going to go into it in detail, but there are opportunities at all phases to reduce structural embodied carbon, and most of these are cost neutral, as we've seen on many projects. So here's how we set ourselves up for a success. We do embodied carbon analysis on every project. We have education on how to read environmental product declarations and other things, how to use EC3 to find environmental product declarations and compare them. We have internal groups that research the most advanced practices and bring them specifically to project teams. And another thing is we have staff actually do the embodied carbon analysis rather than specialists. And what that means is as people struggle with software and they learn it. They learn the terms and the sensitivity around what is important and what is not important in reducing embodied carbon. We do have specialist QA the reports, but having staff do it, we find a lot of success. You can see the tools we use at the bottom, which is Tally for all of our projects, and that includes lead credit, but also just the basic analysis. We use EC3 to search for products because it's got a great database. We use C-Scale for early estimates. And we use Excel for a lot of post-processing and making sure that we understand the data, and all the tools are imperfect in their own ways. Here's the first case study, Founders Hall, that recently won a COTE Top 10 award. We were able to steer the design toward an all-electric mass timber building, which significantly reduced the carbon pollution from it, and also is biophilic. It's beautiful to be in. It's light-filled, and it's got this warm thing, and we also don't need ceilings in a lot of the building because it's mass timber and beautiful. Skipping a lot of the how, we also analyzed all of the embodied carbon that we could using data available in 2019 for this project. The diagram in the upper right shows a few things. Since the mass timber structure reduces embodied carbon, and all electric with mostly renewable energy reduces the operational carbon, the rest of the pieces get fairly large comparatively. We see this as kind of a bellwether for where our industry is going. So landscape, MEP, refrigerant leakage, interiors, all that are big pieces. And in fact, this kind of told us this is where we need to go with our advanced practice, which is let's focus on the things on the right, but we also need to have an awareness of the things on the left. And this led us to do the Path to Zero Carbon series that I mentioned earlier. This is a super deep dive, graphically illustrated into all the pieces of getting to a carbon neutral building, because there's a lot of claims out there of carbon neutral buildings, and there are none in the contemporary world. So we wanted to kind of figure out how to approach that. It's free online, so go there and learn something from it, if or make comments to us if you have comments on it. The second and last case study is a project currently under construction in Austin. It's Austin Convention Center. It started with some lofty goals, including Austin's plans for climate equity and several other documents that address community and climate. But the design team, as always, has to kind of figure out, well, how to turn that into actionable goals. And we turned that into ILFI zero carbon certification and a bunch of other goals that you see on here, including LEED and Austin AEGB. Partway through construction, it's still on track to be the first ILFI zero carbon certified convention center in the world at around 1.5 million square feet. So here's some strategies, including all electric operations, all electric kitchens, 100% renewable energy through Austin Energy's program. And it pushes the boundaries of embodied carbon in the region in lots and lots and lots of ways. All of this fits within a budget, and it's actually the budget for sustainability is a very, very small percentage of the actual cost of the project. So here's some specific strategies. Reducing the weight of the building is a primary one. Reducing excavation. There's a lot of below-grade program for this, and those are big pieces. We don't get credit for those, but they reduce the actual embodied carbon on that. We started analyzing embodied carbon very early in the project in concept design when we only had a cost estimate for material takeoffs, and we were able to turn that into a rough estimate and figure out how we were doing. The region actually has fairly low embodied carbon concrete already, so reducing this has been a challenge. So there's a new slag plant in Houston, and getting some slag into some of the mixes helped us reduce beyond that. We also incorporated mass timber into roof structure and ceilings, which was a cost and carbon win. We also reduced or increased the strength of the steel, which reduced the total steel weight, which was also a cost and embodied carbon win. We worked on low carbon steel with suppliers, rebar, aluminum curtain wall, many other materials and envelope and interiors to reduce that. And it's been an awesome team. If you look up this project, you'll see the team, and they're awesome. One of the biggest opportunities to reduce embodied carbon we have is salvage and reuse, and that's something we've really pushed on this project. Digging into it just a little bit. Before the existing convention center was demolished, the team did multiple salvage walkthroughs to see what was useful, and we talked to the contractor with a list of 20 or more materials to estimate the cost effectiveness of salvaging and reusing each material within the project, self-salvage. We ended up with a list on the right, including 60-foot trusses that are actually taken down now and stored and will be reused in this outdoor pavilion in a warehouse building, as well as 10,000 square feet of metal panel cladding, some grading, mesh, and interior panels. So this is about 600 metric tons of embodied carbon that were saved by salvaging and reusing this. And this is a bit of what some of the strategies look like. You can see some of the trusses on the right and the metal cladding panels being taken down on the right, the sunshade bar grading in the existing location on the left, and where it's going to go on the new building, and some of the mass timber. So with that, that's a super quick dive into a couple projects and how we approach embodied carbon at LMN. So we're ready for the next presenter. Thanks.
All right. Good morning, everyone. My name is Ty Lanning. I'm with COTE Architects. I'll share my screen here in a moment. I've been with COTE for about 10 years. I'm an architect and a project manager here, and have developed a specialty for healthcare design. I also have a long history of interest in sustainability. I actually worked for Ed Masria and Architecture 2030 in New Mexico for a couple of years. After that, I was the COTE chair in LA, and have since moved to San Diego, but I've been a working on really what we like to consider high performance, sustainable buildings that are quite large, quite complex, and I'll walk you through a couple of them now. Okay. Tale of Two Buildings. I'll be a little vague because the project's actually in construction now, and we've been asked by the client to be not totally transparent with the details. So I've wiped off logos, things of that nature. The first building, there are two buildings on the same campus. It's a hospital and the supporting energy center. Um, Groundbreaking has begun. Um, this is the campus. There's an existing hospital, which is really integrated with all the other medical office buildings on the campus. And there's an existing energy center. And we have to build a new hospital on the campus before the old ones come down. So we got to keep the old one totally operational while building a new one. These two buildings, these two warehouse buildings, have actually since been demolished. And we did try to consider whether any of the material could be salvaged. For a project like a hospital, I think it's quite rare in my experience that any materials from that exists already can be reused. Not to say, you know, not to say that with any certainty, um, but we'll probably reuse some of the trees that had to come down. But that's almost just for show at that point. You're not going to see that in a graph. Um, but we'll get to some of the other reduction strategies. So hospital there with the H, energy center with the E. The hospital, we're working on an LCA. We don't have it finished, but we've been able to incorporate some of the high recycled content steel, low carbon concrete, things of that nature. I don't have those graphs yet. This is what it will look like. About 615,000 square feet. We use shading, it's a very high performance facade. Um, no shading on the north side, etc. I'm going to sort of skim through here. Various frit patterns, reduce glare, reduce solar heat gain coefficient, uh, with a lot of attention to the type of insulation that's used. Uh, this was a site adaptation from a building in Southern California that was transplanted to a colder climate. So on the outside, it looks quite similar, but a lot of detailing was needed to make it work in a new climate with a much higher humidity and much more extreme temperature swings. Um, and I can't skip the emissions. I know that this portion of this part two of the webinar is more focused on embodied carbon, but I do need to point out that, and this is not a C scale advertisement, Jack. Um, the embodied carbon is the red at the bottom. The blue, of course, is at the top. There's some refrigerant associated emissions in there, and energy production emissions. This is for a typical 60% gas powered, 40% electric hospital. And this is an actual project that we've done. Roughly 400,000 tons of CO2 equivalent over the life of the building. Hopefully it should last longer than 60 years. This is a subsequent hospital that's been built, first LEED Platinum hospital in the country. And it has a tri-generation, which is like combined heating and power, but like on steroids. And it still uses fossil fuels, though it still burns them on site, but at a much higher COP. And you can see the reduction is in emissions over the life of the building is roughly half versus the baseline. Another project that we've completed for UCI where it was fully electric, another large hospital that reduced the emissions, even further. So now we're getting down to 125,000 versus 400, and the current project is what we're showing here. And it's out of state. The grid is being cleaned up, but I just can't skip the fact that for a project like this, our low-hanging fruit to reduce carbon emissions was really on the operational side, less so on the embodied side. And we could get that red bar down, but we're already down to a quarter or less of the emissions associated with this project versus the baseline building. And of course, for that number to get to zero, the red and the blue both need to be tackled. Phil, I stole a snapshot from your presentation there a couple of minutes ago. I think that actually matches pretty well the embodied carbon ratio versus the emissions associated for a high performance building like this. So this project really needed to be tackled from both fronts. Again, I'm sorry I don't have the LCA for this project yet. It's underway. But the other building that's associated with that and that's actually providing the power is where we'll spend the second half of this. The Energy Center, which is a standalone, about 25,000 square foot building, provides all of the power for the hospital. Fully electric. These are air source heat recovery chillers in the foreground on the right there. And this will be a fully mass timber building for the primary framing structure. That is a first for us, and it's a first for this client. So I do want to take a moment here to point out that for repeat clients, you do need to, you can't push on all fronts all at once. So we can work with them and make incremental advances and go out on a limb here and there. We've been wanting to do a mass timber building, and this particular project is in a locale where it made sense, and we've been sort of holding that in our back pocket. They agreed to it. That's what the frame will look like. It's not built yet. They're actually digging the foundations for it. I was out there yesterday checking it out. But the the main structural grid will be mass timber, vertical lateral systems with a couple of steel shear walls. You can see that brace frame in the middle, that chevron pattern. Those still needed to be out of steel. I'm going to skip this and get to the good stuff. Yeah, you can see the steel shear walls here in blue. And unlike every other energy center that we've ever designed, we actually really wanted to show the inside of this and make it public facing. So you'll be able to walk by and through, double story windows, you'll be able to actually see the timber structure. I hope it looks like Founders Hall. We'll see. Okay, so getting down to the numbers for this project, we did have an LCA performed. For buildings of this scale, we do that out of house. So this was an added service for the client, which happy to take any questions on how to approach a client with a suggestion like that. You can see the importance here of capturing the benefit of biogenic carbon versus non. So this next table, I think, is probably the clearest slide. On the left is just mass timber, sort of you don't know where it came from. You don't know what it's going to, you don't know how it's going to be processed at the end of its life, at the end of the building's life. That 459 is not much lower than the baseline of 520 over on the right for a steel framed equivalent building. That's only about a 10% reduction in terms of embodied carbon. And of course, this is only looking at the structure, but it's, that's going to be the lion's share of the embodied carbon. In the middle, which is what we've been able to capture for this building, that's almost a 50% reduction over the baseline for embodied carbon because we have EPDs and Forest Stewardship Council certification for the timber. So we can trace where it came from. With the EPDs, we know how much carbon is stored in it. And that's another, a main point of this presentation is if you're going to capture some of the benefits, you do need to proof it out so the contractor actually purchases that product and not some sort of similar product that you might not be able to trace. That level of accountability, I think, is what we what our clients request and need from us so that they can actually get the building that that they're paying for. And yeah, that's the end of my presentation. Thank you.
Awesome. I'll pick it up from here, I think, and let's keep it pretty short, Kate, I would say, just to have time for questions. Is that right?
Yeah, 5 minutes is okay. I know we're running a little
Cool.
bit long, so whatever you
Yeah,
want to share, I think it's important.
cool. All good. No, really appreciated all of those presentations. I'm going to give the briefest sort of run through the summary version. I hope it's exciting that it can be very short about how C-Scale sees supporting the DDX, and obviously our goal is to make this very accessible. So I know that many people here are already C-Scale users. If you're not, we'll find some way to get you in sort of in whatever terms make the most sense to you. Um, at the core of it, T-Scale is a whole life carbon modeling tool. I think exactly to Ty's point, like there's this library renovation project that I'll use as an example. This is what the target scenario looks like. If you show the reductions, it looks like that. You see that obviously there's been major reductions in energy use. So the whole life carbon perspective, the DDX is focused on this. You got to look at embodied and operational together. I'm going to switch screens for a second to look at the data reporting requirements for the DDX embodied carbon. This was shown at the beginning as well. It's this form you have to fill out, and obviously with DDX reporting, there's somebody on the team that's doing the reporting that maybe isn't always the person who will say like was the project designer. And our goal for addressing this that worked really successfully last year for firms like DLR is to just have a PDF export from the project. It'll take a second to generate. It'll save it. It just matches field for field and column for column the data that you need to enter to move it from the report here to here. Whether you're modeling in a little bit of detail or a lot of detail, the whole thing here is just to exactly match every field in every place so that a designer can go and have one on each screen. And until this is automated in the DDX, this has felt like the best way for firms to do it. Just again, a direct match from one data format to another. So nobody needs to guess what is the A5 emissions from, interior construction. You can just move the field over. Okay, so that's sort of reporting on the project level for embodied carbon. There's another thing we've been working on that's been exciting, which is helping sort of with the bulk exporting. And I know that this is always a touchy process because of the way the DDX manages data. So I encourage you that if you're looking to try this, to talk to us and we can sort of make time to do it together. But in addition to modeling project by project, folks in C-Scale look across a portfolio, whether it's a campus of buildings or an internal portfolio, to do things like benchmarking, understand some of the differences, right, between EUI and operational emissions. You can see that they stack up fairly differently. And as these portfolios come together, also to export these bulk reports. This is 20-something projects. And what this will do is it'll generate the spreadsheet that then you can use to bulk import to the DDX. And I've done a pretty good job matching the DDX and all its requirements for the ways the different fields are formatted. And that really is, something we hope helps with this sort of reporting process, not just for one project at a time, but for many. And of course, we'll say the moment where I am demoing is the one where it's going to take a long time. But this will export when it's done. There it is, this spreadsheet, which I can open here. And it takes this kind of gnarly 50-column DDX spreadsheet and fills it with all the data from the project for energy and embodied carbon to make it easy to upload, that into the DDX. So a spreadsheet and a PDF, like really not rocket science, but tools that we're working on to help make DDX reporting easier for firms everywhere, with the idea that every firm can eventually report embodied carbon for every project that they're working on. I'll leave it there. I'll put my email in the chat if people have questions, but again, really happy to support folks however is meaningful. Even just walking them through the DDX template process. If you just want to do that, there's a lot of details there.
Thanks, Jack. And maybe one just thing I was hoping you could elaborate on is it seems like from when I've used it, there's such a range of information that you can put in. So people could spend only, an hour getting some really high level, great information, or can do really granular. Like we've had a lot of our designers, I've been like, here, test this out for me. And they'll spend an hour and they can get pretty far on a really nice summary.
I mean, it's exactly one of the things that I think you touched on too, Ty, that so much of the work we do is constrained by time and resources and what the client's willing to pay for. I appreciated your offer to talk folks on this call through about how to sort of get that ad service. Like how much analysis can you fit into 1 hour of billable time to be able to make actionable decisions or get something a little bit better? Maybe you have a couple numbers, maybe you have 6 hours, maybe you can do the whole LCA and tally because somebody's going to pay for it. Like these are all, I think there's a spectrum here, but really, yeah, C-scale is really focused on low to medium levels of resolution. And we'll be talking more to, we have some work with building transparency sort of pending. I think that C-scale tally EC3 flow is an awesome way to approach project design throughout the whole delivery lifecycle.
Thanks, Jack. And I'll say that Jack and team have been really great at, answering questions on the fly via email or just setting up one-on-one calls. So definitely reach out to them if you want to get to use this tool and see how it works for your firm. If anyone wants to unmute and ask some questions, or you can post them in the chat. I think we did have, let's see, a couple comments. Does anyone want to reply? Let's see, Megan, maybe this would have been oh, there you are, Megan. Do you want to unmute?
Yeah, I can just reiterate the question I sent in the chat. Thanks. Thanks all for really informative session. I just had a question for Ty. I really appreciated how you were transparent in some of the challenges that, a project team can face when trying to approach a client and pitch them a new solution that they haven't implemented before, like mass timber. We've experienced some of those challenges at my firm as well. And so I was curious if you could share a bit more about how you successfully and strategically approached the client and made them, open-minded to both mass timber and performing an LCA. And I was curious if they were a client that was pretty interested in the decarb benefits, or if you, strategically took the story a bit of a different way and focused a lot more on cost and resource benefits. And I know it's kind of all of those things are part of the picture, but would love to hear your approach.
Sure. Yeah, your last point about all of those things being part of the picture, I think is the key here. It's hard to ask a client to just pay for X and receive the benefit of X. For the LCA, we got the data from the LCA. The client now has it, but we also got to the platinum lead threshold. And that was co-architects directing the client to use the LCA to get over that threshold. But it has all of these secondary benefits of now we can, C-scale is great, but it's not at the granular level that an exhaustive LCA is in terms of looking at every single material with the Revit model in actual quantities. So it was a hefty ad service. But we were able to sort of pile on the benefits for no added cost, outside of the LCA cost. And they, that was enough for them. But we didn't have, you can only sell so hard. If they don't want to do it, they're not going to do it. That's what I mean. Like with repeat clients, you don't want to go so far out on a limb that they're like, well, way, too far. But you can start to do things like, hey, for all projects now, because this past hospital had an LCA, we should do this going forward because we've been able to see XYZ benefit from it, whether that's marketing, accountability, et cetera. The mass timber, this project is in Oregon, and the Oregon personnel liked the idea of doing mass timber in Oregon. And we've not had luck in Southern California, where I'm based, getting mass timber projects off the ground. But it was like a shoe-in up there. So we sort of sensed that. And given the locale, that was one of our very first questions with the contractor. Hey, have you ever done mass timber buildings? Yes. Here's a list of them. With that, armed with that assurance, we can then go to the client and say, we've wanted to do this for some time. This is a good project given the locale. The um, the labor force here knows how to build a building like this, and the contractor has experience. So minimizing those risks shows the client that, you are actually looking out for their best interest, not just the architect's design. Hope that answers.
Thank you.
Well, I know we're over time. I put my email in the chat if you want to reach out for any more questions or just generally about the series and resources. We're happy to help TxA COTE, or even if you're outside of Texas, just let us know. But thank you, Jill and Ty, you're still on.
Yes, thank you, everyone. Thank you, Kate.
Thank you. We'll try to post these on our YouTube at some point if you would need to rewatch or send to anyone you know. All right, thank you. Bye.